Hello everyone, welcome back to Infinity Physics. In this lecture, we are going to discuss about law of conservation of momentum. Now, before discussing the law of conservation of momentum, we need to know about two terms. One is a conservation and another is a isolated system. If you can understand these two terms clearly, then you will be able to understand what is the meaning of conservation of momentum. First, let us try to understand isolated system. An isolated system is a system in which the exchange of energy and the matter does not take place. That is, no energy or matter can go outside from the system and no energy or matter can come inside of the system. For example, you know about the thermos, right? So in the thermos, if you keep a cold water, then it will remain cold for a longer time, and if you keep hot water, then it will remain hot for a longer time. It means there is no exchange of heat, there is no exchange of energy between the surrounding and the system, and hence we can say that the thermos is a closed system. So the conservation of momentum can be followed only in a closed system. Now let us try to understand conservation. See, conservation means there is no change. What does it mean? That is, if the system is completely isolated, there is no energy can come inside and no energy can escape from the system, or the mass or momentum, anything cannot escape from the system. It means if you measure the momentum, energy or mass of a system before an hour, and then if you measure it after an hour, then you will find that the total energy of the system is conserved. That is, it is constant. There is no change in the total amount of the energy or the momentum or the mass of a system, and hence we can say that the mass of a system is conserved, the momentum of a system is conserved, or the energy of a system is conserved. Now let us try to understand it with the help of the example. Here we have two pool balls, one is a white and another is a black, and having the same mass. When you hit the white pool ball, it acquires velocity u1 and moves with the momentum mu1, while the ball 2 is at rest and hence it has momentum 0. Then the total initial momentum of the system is pi is equals to mu1. Now, when white ball strikes the black ball, the white ball comes to rest while the black ball starts moving with the velocity v2. As both the ball has the same mass, the black ball moves with the same velocity u1. The final momentum of the system can be calculated as Pf is equals to mv1 plus mv2. Here v1 and v2 are the final velocities of both the ball, but v1 is equals to 0 because white ball comes to rest while ball 2, that is black ball, acquires some velocity v2 which is equal to the velocity, initial velocity of the white ball, that is v2 is equals to u1. Now the final momentum of the system is Pf is equals to mu1, which is equal to the initial momentum of the system, and hence we can say that the momentum is conserved. Now the law of conservation of momentum can be stated as, in a closed and isolated system, the total momentum of the objects before a collision is equal to the total momentum of the objects after collision. Now, in all the cases, the mass of the two body or the two objects which are colliding is not equal. So, we need to derive a general equation, and also we will prove the law of conservation of momentum, that is, the initial and final momentum are same. Now, when two bodies collide, they will apply an equal and opposite force on each other according to Newton's third law of motion. That is, here the force exerted by ball 1 on ball 2 is equals to force exerted by ball 2 on ball 1, but both are equal in magnitude and opposite in direction, and hence we can write F1 is equals to F2, but the directions are opposite and hence we need to put the minus sign, that is F1 is equals to minus F2. Now from the Newton's second law of motion, we know that F is equals to m A, that is mass times acceleration. So instead of F1 we can write m1 a1, and instead of F2 we can write m2 a2. Now we know that the equation of the acceleration is A is equals to v minus u by t. For object 1, the acceleration produced is a1 is equals to v1 minus u1 by t1, and for object 2, v2 minus u2 by t2. But the time of collision is same for both the object, and hence t1 is equals to t2, and therefore it gets cancelled. Now we are remain with m1 in bracket v1 minus u1 is equals to minus m2 in bracket v2 minus u2. Now on opening the bracket we will get m1 v1 minus m1 u1 is equals to minus m2 v2 plus m2 u2. Now take m1 u1 towards the right side and m2 v2 towards the left side, and we will get m1 v1 plus m2 v2 is equals to m1 u1 plus m2 u2. But m1 v1 plus m2 v2 is the final momentum of the system, and m1 u1 plus m2 u2 is the total initial momentum of the system, and hence we can say that the total momentum of the system is conserved. That is, the final momentum and the initial momentum of the system are equal. Now if you have two objects, object A and object B, initially moving with initial velocity ua and ub, then the total initial momentum is ma ua plus mb ub, and after collision if their velocity changes, their final momentum will be ma va and mb vb, where va and vb are the final velocities of the object. Then we can write that the total momentum after collision is equals to the total momentum before collision. That is, ma va plus mb vb is equals to ma ua plus mb ub.